IXL section X.5 Exponential Growth and Decay Word Problems. This IXL is very important, and I'm going to count it for several grades. And the reason why is because it's on word problems, and there's a lot of word problems on your upcoming exam in Algebra 1. Now, I'm going to show you the system to use to get all of these word problems right every time, all right, and how to set them up correctly every time if you follow my system. But again, this IXL is very important, and I'm going to count it for several grades in order to try to motivate you as much as I can to make sure you complete this IXL. Okay, este IXL lo voy a contar para varios grados porque es muy importante. Tienen problemas con palabras donde lo tienen que leer y ponerlo en una función exponencial, y le voy a enseñar cómo hacerlo en cada problema para siempre cogerlo bien. Okay, pero es un IXL muy importante que necesito que hagan si quieren sacar un buen grado en el próximo examen en la clase de álgebra. All right, so here's the key. The key is this little formula that's here. It may look complicated at first, but I'm going to show you that it's simple. The first thing I want you to realize is that the initial amount goes where that lowercase a is, the initial amount. And the rate of growth or decay goes right here where r is, and the number of time periods goes where t is. Again, give me 1 second so that I could demonstrate what I'm talking about. All right, but again, a, the lowercase a is the initial amount. R stands for the rate of growth or decay. And by the way, notice that you're adding the rate of growth or decay to the number 1, all right? It's 1 plus R, and R is the rate of growth or decay, and T is the number of time periods. I know that looks complicated. Give me a second to show you what I mean, and you'll see that it's easy, all right? Esta fórmula es lo que necesitan para hacer los problemas. Yo sé que luce complicado, pero en un momento le voy a demostrar que es fácil. Lo que quiero que se den cuenta es que esta A representa la cantidad inicial siempre. Dentro de los paréntesis es 1 más el rato que está creciendo o disminuyendo. Y T, el exponente T representa los números de tiempo, de periodos de tiempo. All right, so look. This right here, I put like several examples, and hopefully after you see several, you'll see what I mean, all right? On the top, I have exponential growth. On the bottom, I have exponential decay. Let's look at it. Be calm, be confident. I'm going to show you what I'm talking about, all right? Let's just look at these for a second, okay? Exponential growth. I put the formula in every slide. I put the formula right here. Okay, so first of all, remember this is the initial amount. So first of all, let's just look at that part. Look at every example here. There are 150 rare tigers. My 150 is my initial amount. Miguel deposits $500. My $500 is the initial amount. Samantha buys a $200,000 house. $200,000 is my initial amount. A plant is 20 inches tall. 20 is my initial amount. All right, so there you go. There's my first part of my equation. I'm always writing right here the initial amount. En cada ejemplo, ahí estoy escribiendo en esta columna, aquí, la cantidad inicial. All right, and by the way, if we go down here, it's the same thing. Aquí abajo es la misma cosa. Primero la cantidad inicial. Okay, now let's look at the second part. The part that's inside the parentheses. All right, so let me erase all this. Okay, notice that inside the parentheses, it says 1 plus the rate of growth or decay. Okay, so in the first example here, there are 150 rare tigers and the population is increasing by 20%. The rate of growth is 20%, and you add that to 1. Okay, first of all, remember that a percent, you got to change it to a decimal by moving the decimal point that's here 2 times to the left. So 20% becomes 0.20. If you're wondering where's the decimal point in 20%, the number 20 is a whole number, so the decimal point is right here. So I'm moving it 2 times to the left. So 20%, you change it to 0.20. And I add that to 1, which gives me this 1.20. Over here on this one, Miguel deposits $500 in a bank account and he earns 8% interest each year. Change the 8 to a decimal. So 8% becomes 0.08. Or again, the decimal point is here. I got to move it 2 spots to the left. So it becomes 0.08. And when I add that to 1, it becomes 1.08. Samantha buys a house. Whatever, the value appreciates. Appreciates means goes up, okay? Because I know some of you are always, every year somebody's like, what does that word mean? Appreciate means that it goes up. The value appreciates by 15%. 15%, change it to a decimal, it becomes 0.15. So when you add that to 1, it becomes 1.15. A plant is 20 inches tall and it is growing at a rate of 5% per month. It's growing. 5%, when you change it to a decimal, it becomes 0.05 because you're moving the decimal point 2 times to the left. And when I add that 0.05, when you add it to 1, you get 1.05. Right? That is not difficult. That is not difficult, so you need to step it up, right? Because that's what you need to do for these problems. And again, there's a ton of this on your next Algebra 1 exam. You could prepare now or you could suffer later. I think it's smarter to prepare now. All right. Let me just say that in Spanish real quick. And by the way, the exponent would be the number of time periods, which I'll demonstrate in 1 second. All right. For this slide, I made the time periods like they're all the same. In the next, when we start looking at the IXL examples, the time periods are different numbers. All right. But on this slide, I just want to concentrate on the initial amount and the rate of growth or decay. I still got to go over the bottom ones. Give me 1 second to say all this in Spanish. Okay. Así que para lo que está dentro de los paréntesis, siempre se pone uno más el rato de crecimiento. Ok, así que en el primer ejemplo está aumentando la cantidad de tigres por una cantidad de 20% cada año. Un porcentaje siempre se tiene que cambiar a un decimal. ¿Cómo se hace? 20% se mueve el punto decimal que está atrás del cero, 2 lugares para la izquierda. Así que 20% se cambia a 0.20 y ese rato de crecimiento se le suma al número 1. Así que sería 1.20. Aquí, como en una cuenta de ahorro se está aumentando 8% cada año, 8% se cambia a 0.08 y cuando se le suma a 1 sería 1.08. Aquí el valor de una casa está aumentando, appreciates aumentando. Así que está aumentando 15% cada año. Así que 15% es 0.15. Cuando se lo suma a 1, 1.15. Y al final, una planta mide 20 pulgadas y está creciendo 5% cada mes. 5% se cambia a 0.05. Cuando se lo sumo a 1 sería 1.05. All right, now that we got that, let's look at the decay. All right. All right, so when it's decay, that's a negative number. All right, so look at my first example. There are 150 rare tigers. 150 is my initial amount. All right, this part is important, so please pay attention. The population is decreasing by 20% each year. That means the rate of decay is, you can think about it like this. It's going down by 20% each year. So that means it's going down by 0.20. If I change 20% to a decimal by moving the decimal point 2 spots to the left, it's 0.20 or 0.2, however you want to think about that. So if I subtract 0.2, let me erase all this. Remember, it's 1 plus the r. If r is negative 0.20, when I subtract that, I'm going to get 0.80, which is what's right here. Okay? Si está bajando por 20%, tengo que restar 0.20 o 0.2 de 1, que me daría 0.80. All right? Another way you can think about it is, here's another way you can think about it if by any chance you find that confusing. You can also think about it as 100% minus 20% equals 80%. But you got to change the 80% to a decimal, which is 0.80 or 0.8. I'm just writing, you don't need to write the last zero, but I'm writing 0.80 so that nobody gets confused, okay? But obviously you could write 0.8. Ok, también pueden pensar de 100% menos 20% sería 80%. Y cambio 80% a un decimal que sería 0.80 o 0.8. Alright, over here, the one with Miguel, it's depreciating. That means going down. Depreciate is when it goes down in value. Ok, depreciate quiere decir que el valor está bajando. 3% each week. So you can think about it as 100% minus 3% equals 97%. And 97% as a decimal is 0.97. That's probably the easiest way to think about it now that I think about the two different ways to say it, all right? So let's think about it that way. Okay? 100% menos 3% es 97% y si lo cambia a un punto decimal, sería 0.97. Or if we go this way, it would be 1 minus 0.03, which would be 0.97. All right? That's the other way to think about it. Over here, depreciating by 15%, it will be 85%, which you write it as 0.85. Okay? 85% que se escribe 0.85. If it's going down, losing weight at a rate of 8% each year, that will be 100% minus 8% is 92%, which you write 0.92. Ok, si está bajando por 8%, 100% menos 8% sería 92%, que se escribe como un decimal 0.92. All right? I hope that makes sense because that's super important and that's not difficult. That's easy. The calculator is going to do all the heavy lifting, all right? You just got to set it up correctly. And by the way, you're going to need a calculator. Speaking of which, let me add a picture of a calculator. I meant to do that and I forgot to this PowerPoint. Just one second. Okay, I added my picture of a calculator and let's look at our first example. Okay, so it says scientists are modeling the spread of a hypothetical virus. In their computer model, there are currently 300 people infected. Right there is my initial amount. There's 300 people infected. All right, so you don't have to write this fancy part at the beginning. All right, just 300. That's my initial amount. It's gonna be like this on pretty much every problem. So start identifying the pattern. So we're starting off with 300 people infected, and the virus. This is a very timely, a timely example, very relevant. The virus is spreading at a rate of 10% each day. Right? So it's spreading at a rate of 10% each day. It's growing. The number of people infected are growing if the virus is spreading. 10% each day. That means you can think about it as 100% plus 10% equals 110%. But I got to write it as a decimal, which would be that. Or you could think about it as the way it describes it here in the formula, 1 plus R. 1 plus, if it's 10%, I got to write it as a decimal, which would be 0.10, which would become 1.10. Either way you think about it, in the parentheses, you're going to write 1.10. Okay, now look, here's the question. Remember right here, the exponent is the number of time periods. How many people will be infected in 7 days? So my exponent is going to be 7. Let me translate that to Spanish real quick. Okay, así que hay un virus que se está pasando y estamos empezando con 300 personas infectadas. Ok, si se está aumentando la cantidad de personas infectadas por un rato de 10% cada día, ok, 10% es 0.10. Recuerden que el rato de crecimiento se le suma a 1, así que 0.10 se le suma a 1, te da 1.10. Y aquí el exponente es la cantidad de periodos de tiempo. Así que cuántas personas van a estar infectadas después de 7 días. Así que aquí es como se hace la ecuación. por poco dije la infección. Alright, así se escribe la ecuación. No escribí la parte al principio porque no es necesario. Okay, ahora déjame enseñarle cómo ponerlo en la calculadora. Alright, so look, in the calculator, you always got to follow the order of operations. All right. Again, keep in mind that this little the pattern of how I wrote everything is going to be pretty much the same on almost every question. All right. El patrón de cómo escribí todo es lo mismo en casi todas las preguntas. All right. So I'm going to follow the order of operations. The order of operations is first you do what's inside parentheses, but there's nothing to do here. So let's go to the second step. The second step is exponents. So first I got to do 1.10 to the 7th power, and whatever that gives me, I multiply it times 300. All right, if you have your iPhone, you got to turn it sideways in order to get these additional buttons. All right, so turn your iPhone calculator sideways, and this button right here is the one I'm going to use. This button allows you to put whatever exponent you want. All right, so in your calculator, you would first enter 1.10. Then you hit this button. Then you're going to tell the calculator what exponent you want, which is 7. So hit 7, and then hit equals, and then hit times 300 equals, and that'll give you your answer. All right, I'm going to say it one more time before I say it in Spanish. Turn your iPhone calculator sideways. So first you're going to enter 1.10. Then you hit this button right here, x to the y power. That allows you to tell the calculator any exponent you want. So I want the exponent of 7. So now enter 7. Now hit equals right here. Hit the equal button. Now hit the times button. And now enter 300. And hit equals. And your answer, they want you to round your answer to the nearest whole number. So your answer would be 585. 585 people are infected. Okay, así que en la calculadora primero ponen 1.10 porque tengo que seguir la orden de operación. Así que primero tengo que hacer este exponente antes de multiplicarlo con 300. Así que en la calculadora, lo tienen que poner la calculadora de lado para tener estos botones. Si tienen un iPhone, pónganlo de lado. Ok, así que primero pongo 1.10, le doy a este botón que me deja, eso le está diciendo a la calculadora que le va a decir qué exponente tú quieres. Así que a la vez que le da este botón, pone 7, le tiene que poner, tocar igual a, y después pone multiplicado por 300 igual a. Y te debe dar este número cuando lo redondean al número entero más cercano. All right, let's move on to the next example. El próximo ejemplo. All right, so a union has successfully negotiated for its members to get 5% raises annually. Okay, if a union member currently has a salary of $58,000. All right, so that's my initial amount. The union member currently has a salary of $58,000. That's my initial amount. And here it says that he's getting a raise of 5% annually. All right, a raise. That means his pay is going up 5% annually. So you can think about it as 100% plus 5% equals 105%, which when I change it to a decimal will be 1.05. Or you can think about it as 1 plus 5% when I write it as a decimal is 0.05, which will equal 1.05. However you think about it, the number you write here is 1.05. Now the time period is 9 years. Now you just do the rest in your calculator. Again, the way you enter it would be 1.05. Hit this button right here. Put 9 equals times 58,000 equals. Let me do it myself, see what I get. 1.05 to the 9th power equals times 58,000 equals. So what will his salary be in 9 years? If I round it to the nearest cent, it'll be 89,977.04, which is pretty good. Alright, así que en la calculadora tienen que poner 1.05, le dan a este botón para decirle a la calculadora que quieren un exponente de 9 igual a multiplicado por 58,000 igual a, y le da esta cantidad. Así que después si el miembro del union le está aumentando el pago 5% cada año y él en estos momentos tiene un salario de 58,000, ¿qué va a ser el salario en 9 años? Ok, sería esta cantidad. All right, let's move on. All right, in Newberry, the use of landlines has been declining, going down at a rate of 5% each year. A landline, if you don't know what that is, those are the phones that used to be connected, like in your house, to the telephone poles, but now nobody has because we all use cell phones. Back in the day, kids, that's what we used. All right, anyways, so the use of landlines has been declining at a rate of 5% every year. If there are 26,000 landlines this year, that's my initial amount. That's my starting point. 26,000. So if it's declining 5% each year, 100% minus 5% is 95%. And 95% written as a decimal is 0.95. That's easy. I don't want to hear you guys whining that you don't get it. Step it up. That's a piece of cake. That's not difficult, right? If there are 26,000 landlines this year, how many will there be in 3 years? So my exponent is 3. The rest, put it into the calculator. All right, I already explained several times how to do it, so you guys should be able to do it now. And the answer you should get, round your answer to the nearest whole number, would be 22,292. Should be your answer. Ok, así que si el uso de los teléfonos en la casa que están conectados a... I don't know how to translate that, so it's late. I'm making this video very, very late and I'm not gonna look that up right now, okay? El uso de los teléfonos de la casa está... cada año está cayendo por 5%. Si empezamos con 26,000 de esas líneas en la casa este año, ¿cuánto van a haber en 3 años? Así que si sigue bajando 5% cada año, 100% menos 5% es 95%, y escrito como un decimal sería 0.95. Lo demás, háganlo en la calculadora. Ya expliqué cómo hacer eso. All right, next one. All right, this one I need you to listen to me because this one's it's the same, but I'm gonna tell you 2 different ways to do it, and this problem comes up several times in this IXL. All right, so this one I definitely recommend that you stop what you're doing and listen to me a second, because it's a little confusing. All right, so it says you have 288 grams of a radioactive kind of barium. If its half-life is 18 minutes, how many will be left after 54 minutes? All right, so first of all, the obvious part is that this is the initial amount, 288 grams, all right? So that's my initial amount. Okay, now the tricky part is everything else. A half-life means that, like for example, this part right here, if its half-life is 18 minutes, that means after 18 minutes, half of this stuff will have evaporated or something. I'm not a radioactive expert or anything. But after 18 minutes, there'll be half of this left. So after 18 minutes, we'll have, if you divide this by 2, you'll have 144 grams left. After 18 more minutes, again, there'll be half left, etc. Okay, so look, I'm going to tell you 2 ways to do it, all right? Okay, the question is how much will be left after 54 minutes? Again, pay attention because this question, it comes up several times in this IXL just with different numbers. All right, so notice something. This number, my bad. This number is a multiple of this number. All right, every time they give you this problem, it's the same thing. So 18, in other words, 18 times what is 54? If you try a few different choices, 18 times 3 is 54. Okay, 18 times 3. So let me tell you the 2 different ways you could do it. Again, 18 times 3 is 54. The first way you could do it is you start with 288. After 18 minutes, you're going to have half of this left, which will be 144. After 18 minutes again, you're going to have half of this left. Wait, hold on. Let me write this better. After 18 minutes more, you're going to have half of that left, which will be 72. And after 18 minutes more, you're going to have half of this left, which will be 36. That's my answer, 36. What I did, here's another way to think about it. I said 18 times 3 is 54. That means basically you got to divide this in half 3 times. 288 divided by 2. Whatever you get, divided by 2 again. And whatever you get, divided by 2 again. I did it a total of 3 times. Because this 18-minute period happens 3 times. That's one way you could do it. It's fast and it's pretty easy. All right, so that's my answer. Now, if you want to use my same system, I want to show you how you could do it with my same system. You start off with the initial amount, which is 288. A half-life means that there'll be half of this left. Half-life means that it's going down by 50%. So 100% minus 50% is 50%. And 50% written as a decimal is 0.50. I'll say it again. A half-life means that you're going to have half of this left. So that's why I'm multiplying times 0.50. Now, what number do I put for the number of time periods? 3. 3, because every 18 minutes, it's going down by 50%. And this 18-minute mark is happening 3 times. 18, 18, and 18 give you a total of 54 minutes. 18 plus 18 plus 18 is 54, or 18 times 3 is 54, however you want to think about it. But this time period is happening 3 times. If you do it like this in your calculator, you'll get the same answer, 36. All right? So whichever way you prefer to do it, but the answer is 36. I'll go through it again when I trust me, I got another example like this, maybe more than another example, because it came up several times when I was doing this. And I'll go over it again. It's not difficult, you just got to do like 1 or 2 of them before you kind of get it. Este es un poquito diferente. Ok, así que dice que... Espera, déjame ver cómo traducir esto correctamente. 1 second, please. Ok, así que en español deben poner atención a este problema porque es un poquito más diferente y sale varias veces durante este IXL. Lo voy a explicar de 2 maneras diferentes. Dice que tienen 288 gramos de algo radioactivo. Ok, y aquí dice... que la media vida es 18 minutos, ¿ok? No sé si lo estoy traduciendo perfectamente, pero básicamente después de 18 minutos van a quedar la mitad de esta cantidad, porque la otra mitad está evaporada, ¿ok? Así que la media vida es 18 minutos. Así que cada 18 minutos queda la mitad de esta cantidad. ¿Quieren saber cuánto van a quedar después de 54 minutos? Ok, siempre estos números, este número siempre va a ser en estos problemas un múltiple de este número. En este caso, 18 por 3 te da 54. Así que este periodo está pasando 3 veces. Así que una manera de hacer este problema es, si empezamos con 288 y cada 18 minutos queda la mitad, es dividir 288 por 2 y hacer eso 3 veces. Así que 288 dividido por 2 sería 144. Lo divido otra vez por 2 para coger la mitad de esa cantidad, que sería 72. Y ahora lo divido otra vez por 2. Así que la mitad de 72 sería la respuesta final, que es 36. Se puede hacer de esa manera. Otra vez lo hice 3 veces porque estos 18 minutos... pasan 3 veces durante 54 minutos, porque 18 por 3 es 54. Ahora, si lo quieren hacer del mismo sistema que yo estaba usando, 288 es la cantidad inicial. ¿Ok? Si cada 18 minutos lo que va a quedar es la mitad, eso quiere decir que está bajando por 50%. 100% menos 50% es 50% y 50% escrito como un decimal sería así. Ahora, ¿qué pongo para el periodo de tiempo? Esto pasa cada 18 minutos y en 54 minutos esto pasa 3 veces. Así que el periodo de tiempo sería 3. Si ponen esto en la calculadora le da la misma respuesta que sería 36. Otra vez, este problema es importante porque sale varias veces durante el IXL con diferentes números, pero básicamente la misma cosa. All right. So let's look at this one. Next example. Brett has 800 in his savings account. That's his initial amount. The interest rate is 2%, compounded annually. Don't worry too much if you don't know what that means. All right. For now, ignore it. For this IXL, just you don't have to know the details of what that means. All right. But the interest percent basically is going up by 2% each year. That's what that means. All right. Basically. So 100% plus 2% is 102%, and written as a decimal, that's 1.02. All right, to the nearest cent, how much interest will he earn in 1 year? So the time period is 1. Okay, now this right here, I got to point out something that's very important, so be careful when you get these questions. All right, let me first get the answer, and let me show you what you got to watch out for. That even if I'm going fast, I made this mistake on one or two examples because I didn't read the question carefully. All right, so I multiply 1.02 times 800, and I get 816. When you multiply that, you get 816. However, that is not my answer. Let's look at the question again. The question was not how much money will he have after 1 year. The question is how much interest will he earn in 1 year. The interest is the amount of money that was added to his initial amount. His initial amount that he put in the bank account, in the savings account, was $800. After 1 year, he had $816. So the interest is $16. If you're in a hurry, like I was, you're going to write 816 and get it wrong and lose points on the IXL because you didn't read the question carefully. So slow down and make sure you're careful because these types of questions came up for me several times during the IXL. So watch out for those. All right. Ok, así que en este problema, ok, Brett tiene $800 en una cuenta de ahorro y está ganando interés de 2% cada año. Así que aquí está mi ecuación. Ahora, tiene que tener cuidado porque cuando hago mi ecuación, lo que cojo es que al fin de un año, él tiene $816. Pero la pregunta no era qué cantidad de dinero tiene al fin de un año. La pregunta es cuánta interés él va a ganar en un año. El interés es la cantidad que ganó encima de los $800 que él puso en la cuenta. Así que en este caso sería $16 de interés. Así que tienen que leer y tener cuidado porque esto sale varias veces durante este IXL. All right. Here we go again with another one with the half-life thing. All right. So let's look at it. All right. So how much of a radioactive kind of, I'm not even going to try to read that word. No, I will try it. Let me go ahead and try. Praseodymium. Something like that. Praseodymium. That's my guess. All right. Will be left after 34 minutes. If the half-life is 17 minutes and you start with 5,440 grams. So obviously 5,440 is my initial amount. The half-life means I'm going to multiply by 0.50. Okay, now I'm going to do it both ways, all right? So look, they want to know how much is going to be left after 34 minutes if the half-life is 17 minutes. That means every 17 minutes, there's going to be half of it left. So 17 times what is 34? I mean, that's easy to figure out. 17 times 2. 17 times 2 is 34. So that means that time period of 17 minutes occurs 2 times in 34 minutes. So you could either do it this way or if you find it easier the other way, let's do it the other way as well. So you start off with 5,440 and you're going to have half of it after 17 minutes, which means you would have 2,720. And then after 17 more minutes, you're going to have half of that left, So you would have 1,360. Right? So you could do it either way. They both should give you the same answer. Ok, así que lo pueden hacer de las dos maneras y te da la misma respuesta. Ok, otra vez tienen algo radioactivo y después dice que después de 17 minutos, la media vida dura, la la duración, no. La media vida dura 17 minutos. Si empiezan con esta cantidad, ¿cuánto va a quedar después de 34 minutos? Así que 17 minutos pasa dos veces durante 34 minutos, porque 17 por 2 es 34. Así que o puedo dividir por dos veces, o coger la mitad dos veces para encontrar la respuesta, o hacerlo de esta manera. All right, here we go again with the half-life. But like I said, after you do two or three of them, you should realize that it's not difficult, right? Okay, aquí tengo la misma cosa, right? So it says I start with 6,880 grams. And again, there's going to be questions like this on your Algebra 1 exam. Get it now and it'll be easy when the test comes around, right? I start with 6,880 grams. That's my initial amount. When we're talking about the half-life, it's going to be 0.50 in here. I already explained why. All right, now the time period. They want to know how much will be left after 312 hours if the half-life is 78 hours. So 78 times what number gives you 312? All right, just think 8 times what will give you a number that ends in 2. And that's probably going to be it. Again, 8 times what number will give you a number that ends in 2? Well, I know 8 times 4 is 32, so it's probably that one. 8 times 4 is 32, carry the 3. 4 times 7 is 28, plus the 3 that I carried is 31. There's my answer. So 78 times 4 is 312 hours. So that means that this time period of 78 hours is going to happen 4 times. So I could either do it that way, or I could divide 6,880 by 2 and do that process 4 times. All right, now on this one, I'm gonna do this one. I think it's easier in my calculator. All right, so 0.50 to the 4th power equals times 6,880 equals, and my answer is 430. Again, I would do it this way. I think it's easier. All right, so in your calculator, you would put 0.50, then you hit this button. You tell the calculator that you want a 4 in your exponent. Then you hit equals. Then you press times. You enter 6,880 and hit the equal button again. And it'll give you this answer, okay? Así que empiezan con esta cantidad, 6,880 gramos. La media vida es 78 horas. Y quieren saber qué cantidad queda después de 312 horas. 78 por 4 te da 312. Así que este periodo de tiempo ocurre 4 veces. Por eso es que puse un 4 aquí. Si prefieren de la otra manera, tendrían que dividir 6,880 por 2 y seguir haciendo eso, dividiendo por 2 un total de 4 veces para coger la misma respuesta que yo cogí usando esta ecuación o esta fórmula. All right, next one. A social networking site currently has. I think I'm gonna wrap up this lesson soon because it's taking a long time. A social networking site currently has this amount of members. So that's my initial amount. But the figure is dropping by 10%. So right by now it should be automatic. If it's dropping by 10%, I'm going to put 0.90 here because 100% minus 10% is 90%, and 90% as a decimal is 0.90. How many active members can the site expect to have in 9 months? Because this is happening every month. Así que un sitio que tiene esta cantidad de miembros está perdiendo miembros 10% cada mes. Así que cada mes está cayendo por 10%, 100% menos 10% te da 90%, y 90% escrito como un decimal sería 0.90, que es lo que escribí aquí. Después de 9 meses, ¿cuántos miembros hay? Alright, so 0.90 to the ninth power equals times 77,630 equals, they want me to round it to the nearest whole number, 30,075 active members, right? All right, another one with the half-life. It says you start off with this amount of grams. Like I said, these half-life problems come up a lot in this IXL, and also there's questions like this on your upcoming exam. All right. So this is my starting amount, my initial amount, and whenever it's the half-life, you put 0.50. Okay, so the half-life is 76 minutes. How much will be left after 152 minutes? So 76 times what number? Whoops, that should be a question mark. Equals 152. It's pretty obvious that 76 times 2 is 152. So the time period, there's two time periods. Or you could do 13,856 and divide it by 2 times. I'm going to do it with the formula. So 0.50 to the second power times 13,856 equals, my answer is 3,464 grams. All right, guys, this will be the last example, all right, because they're all the same thing. So Springtown has a population of 46,869 people. That's my initial amount. Okay, esto es mi cantidad inicial. The town has been seeing its population decline by 10% every year. That means it's going down 10% every year. So 100% minus 10% is 90%. Written as a decimal is 0.90, okay? La cantidad de personas está cayendo 10% cada año, así que 100% menos 10% es 90%, escrito como un decimal sería 0.90. What will be the population in 10 years? ¿Cuántas personas van a haber en 10 años? Alright, so my exponent is 10. So in the calculator I do 0.90 to the 10th power equals times 46,869 equals, and if I round to the nearest whole number, the population is going to be 16,342. All right, there's my answer. All right, once again, for anybody that logged in late, this IXL is super important because there are a lot of word problems like this on your upcoming Algebra 1 exam. So I'm going to count this IXL for several grades. So make sure you do it, all right? I'll let you guys know how many grades I'm counting it for. But I'm trying to motivate all of you to do it, okay? But that's it for these examples. Make sure to look at the video if you need help because I covered every type of question that's on this IXL. All right, that concludes this lesson. Hope you guys have a great rest of your day, and I'll see you guys next class.